In this class, we will learn the mathematical representation of a phasor in both the r angle theta, that is polar form, as well as in the rectangular form. And also, we will discuss the some fundamental or basic AC circuits involving R, L, C, R alone, L alone, L alone, C alone, and then a combination of these R, L, RL, RLC, RC, etc. So, uh, for in the starting, in the previous class we have discussed the phasor modeling, phasors, and how to represent the mathematical equation like V equal to Vm sin omega t in phasor form, in polar form. Okay, and if you have the polar form of a phasor, then you can you can convert that polar form into the rectangular form by the equation which you have studied in your plus 1 plus 2 classes. That is nothing but yes, x plus x plus I, right? I is our notation for imaginary coordinate. So x plus iy is equal to r into cos theta plus I sin theta. But in the entire electrical engineering, we are going to have the new notation for this I. Okay, this is I, that is imaginary. Actually, this I means imaginary, but in electrical engineering, that is not imaginary, it is very much real. Okay, so that means you have, I'm replacing this I with J. The notation is J. Okay, I. Yes. So then we will have an example in which we will convert the polar form into rectangular form. For example, I have the polar form. We have a 5 angle some theta. So this is nothing but your r, and this is theta angle. So r, that means for example 5 angle 30 degree I have. So this is r and this is theta. So r angle theta. So r into, so you if you convert that into rectangular form, what you will get is r into this, apply this formula. So 5 into cos 30 plus j sine 30. Okay, so your the that will be equal to 4.33 plus j 2.5. So this, and again, if we have the phasor in rectangular form like 5 plus j 4, in this is the rectangular representation of the phasor, and you can convert that into r angle theta form. That is where r is equal to under root if is 5 square plus 4 square. That means if we have a plus jb in rectangular coordinates, rectangular form, then if you have to convert this into r angle theta form, then r will be equal to under root a square plus b square, and theta is equal to tan inverse V by A. So R is this according to formula, and theta will be tan inverse 4 by 5. So that will be, so in polar form will be 6.4 at an angle 38.66 degree. So this 6.4 for R will be the magnitude of our phasor, and this theta will be the phase angle which is measured from the positive x-axis. So like this, we have the phasor, and this is our magnitude of phasor R, and theta phase angle is this. Okay, so this is our phasor, and if you project this phasor onto x-axis and y-axis, then you will get this as x, and this is y. So x plus jy will be our phasor, and that will be equal to r or z. This is z. Okay, and magnitude of this phasor, that will be equal to r. Okay, r, and that's equal to under root x square plus y square. Okay, so if this is b and this is a, then a plus jb. So arbitrarily I have taken x and y. So, and the angle theta will be equal to, if you take tan theta from this triangle, you will get opposite by adjacent, that is y by x. So theta will be equal to tan inverse y by x. Okay, so this is the two form or two representation of the complex numbers, that is in polar form as well as in rectangular form. So why we use this polar form and rectangular form? The intention is nothing but to simplify our calculations, all calculations. So by thumb rule, you have to keep in mind that when addition and subtraction, okay, addition or subtraction has to be performed, for perform in the case of, that means addition or subtraction has to be performed or applied to a phasor, to one to two or two or more phasors. Okay, then rectangular form is preferred. And that yields that, or that gives the fastest solution. Okay, and if multiplication and division of two faces of two or more faces, two or more faces has to be performed. Then the polar form of the phasor is the polar form or polar representation of the phasor of the phasors is preferred. Okay, so this you have to keep in mind while solving the problems related to phasors. Okay, then and also we have the multiplication and multiplication, division, subtraction. That means algebraic operations on a phasor. Then suppose we have, yes, that is a plus jb. If you have, sorry, a plus jb, this is a plus jb and one phasor, and c plus jd another phasor. So if you have to add or subtract these two phasors, then this is simple, that is a plus c plus j into b plus d. So this is the complex numbers, like our complex number addition. And then subtraction is also just like that. Then minus, if it is minus, then real part uh, subtracted, a minus c plus j, then b minus d. So like this. Okay, and if the multiplication and division is to be performed, then we prefer the polar form of a, or polar representation of a phasor. Okay, suppose the two faces are r1 at an angle theta 1, and the phasor 2 is r2 at an angle theta 2. Okay, then I have the multiplication. Suppose this is my v1 phasor and this is my v2 phasor. Okay, then if v1 phasor into v2 phasor will be equal to, yes, the magnitudes r1 and r2, you simply multiply r1 r2. Okay, then the multiplication of phase angle, multiplication of two phases, then the angle is added, theta 1 plus theta 2. Okay, so this will be a new phasor v phasor. So what will be the magnitude of this v phasor? That will be equal to r1 and r2, and the phase angle will be, and it is denoted as angle, sorry, this denoted as angle cone. Okay, angle theta, that will be equal to theta 1 plus theta 2. So this is our algebra of two phasors in polar form as well as in rectangular form. So just you have to recollect what you have studied in your +1 and +2 classes. So that's all. Then now another small topic we have to discuss, that is rotation of phasor by 90 degree. Rotation of phasor a phasor by 90 degree. Consider a phasor represented by a complex number, that is my notation is a. Okay, so a is equal to, you can take any notation, a, b, c, d, z, anything. Okay, so a equal to 3 plus j4. This is in rectangular form, and that will be in polar form, that will be equal to 5 at an angle 53.1 degree. Okay, now this phasor, so you have no doubt that this is a phasor, and this phasor you can draw like this. I'm drawing the, yes, my x and y axis, and the phasor of representation will be like this. Okay, this is 5, angle will be 53.1 degree, and rectangular representation will be, and this will be 3, okay, 0, sorry, 30 point, and this will be my 4 point. Okay, then yes, now I'm going to multiply this phasor A by J, operator J. So in electrical engineering, this is not no more. You can call it as an imaginary. This is, I'm representing it as J. Okay, and I'm exclusively taking it as an operator. So let us multiply this phasor by the operator J. So then what you will get is another phasor you will get, that is B, and that will be equal to J into A, and that will be equal to J3, okay, plus J into J, sorry, into J4. That means equal to, okay, J3, J into J is J square, that is -1, right? So -4. So that will be equal to -4 plus J3. So that will be the, yes, my my rectangular form, rectangular representation of the new phasor, that is B, which is obtained by multiplying J with our old phasor, that is this A. Okay, so if you represent the phasor B, then what in Cartesian coordinate, then -4 is this, somewhere here. This will be -40 point. Okay, and I have plus J3 on the imaginary axis, that is J axis. So this will be 3 somewhere here. Okay, this will be 0, 3. So somewhere here. Okay, and the phasor in the polar form will be r angle theta, where r is equal to under root 4 -4 square plus 3 square. Again, it is nothing but 5, right? 5. And phi at an angle tan inverse 3 by -4, 3 by -4 plus 3 by -4. So that will be equal to 5 at an angle tan inverse plus 3 by -4. That means it is in plus 3 and -4. That means 3 is your y coordinate. So y is positive and x is negative. So y positive, x negative means your second quadrant. This is first quadrant and this is second quadrant. So second quadrant. So tan inverse. So what you will get is, yes, this will be equal to pi by 2 plus tan inverse 3 by 4. Okay, so that will be equal to 5 at an angle pi by 2, or I'm going to write it as, let us identify this as 90 degree. So 90 degree plus tan inverse 3 by 4. So on calculator you take the 3 by 4 and tan inverse of 3 by tan inverse of 3 by 4. Okay, so then what you will get is 53.1 degree you will get. Okay, so this is So I'm going to conclude here, means a phasor, a phasor that is A, okay, which is when multiplied by j, then it rotates in anti-clockwise direction or counter-clockwise direction, anti-clockwise or counter-clockwise direction. Okay, that means in positive direction by 90 degrees. Okay, so that means here if yes, our conclusion will be yes, we have multiplied the phasor A with J, that is so that we got a new phasor, that is B, and you have, if you compare this, okay, this answer phi at an angle 90 plus 53.1 degree, and the A phasor is nothing but 5 at an angle uh, yes, 5 at an angle 53.1 degree. Okay, so yes, if you compare A and this B, okay, if you compare, then the conclusion is that, so yes, the magnitude remains same, that is 5. On multiplying by the operator j, the magnitude is not changed, okay, magnitude is same, but the phase angle got changed from 53.1 degree to 53.1 degree plus 90 degree. So that means the phasor A, which is when multiplied by j, rotates in anti-clockwise direction, okay, that means in positive direction by exactly 90 degree. Okay, so that means this A phasor is rotated in the counterclockwise or anti-clockwise direction, that is in this direction by exactly 90 degree. Okay, so this is what you mean by the multiplication of the operator j to a phasor. Okay, so like our time traveling, that means if you operate a phasor with j, okay, or if you multiply a phasor, an arbitrary phasor A with respect to j, that got rotated in the positive direction by an angle 90 degree. Okay, and similarly, if you multiply the same phasor the same phasor A with minus j, then it is the phasor A is rotated in no, in clockwise direction by 90 degree. That means if you operate this phasor A with minus ja, then this phasor will be rotating in clockwise direction, okay, by exactly 90 degree. So this will be 90, this will be 90, so 90 degree. Okay, so this will be your minus j. Okay, that will be equal to another phasor C. Okay, so that this ja and minus ja exactly 180 degree out of phase, we will say out of phase. So if you observe this JA and minus JA, JA and minus JA, only minus 1. So this, if you multiply this J, that is phasor B, with minus 1, then you will get C phasor. C phasor. That means if you multiply a phasor by minus 1, then that phasor is going to rotate in the clockwise direction by 180 degree. Okay, so that is our final conclusion. So now we are moving on to our next topic, that is power and power factor. So we have discussed, we studied the power in DC circuits. We have studied. That means if capital V is our voltage and capital I is our current, then power is equal to P is equal to V multiplied by I, and the unit of power is watt. Okay, so this is our equation of power in DC circuit. But when coming to AC circuits, actually we have to consider the another term known as the power factor, so that you can define the power in a AC circuit. Now consider a simple AC circuit like this. So this is this notation. This symbol is nothing but your AC waveform, and this is okay at one instant of time. Let us say t equal to t1. This is the polarity of our sinusoidal waveform. Okay, so and it is connected to a load. Load is represented by a box. This is our load. That means this is suppose you can imagine like this. This is your KCB supply, and this load is anything in your home, electrical apparatus, any electrical apparatus in your home. Okay, so this is our AC circuit, and this AC source is delivering power to the load, and let I be the current flowing through this AC circuit, and this AC source is V, and that is equal to Vm sin omega t, and this the current drawn by this load is I is equal to suppose it is two phases. Okay, V means small v means it is a phasor, and I small I means it is again you can represent it as a phasor. Now suppose let us imagine that this V phasor and I phasor, we have a small relationship, and this I phasor represented by notated by the I phasor I bar, and V phasor notated by V bar is lagging. I phasor is lagging the V phasor by an angle theta. So what will be the equation of our I phasor? So I phasor will be equal to the instantaneous value of I, E will be equal to, let us say the peak value is Im, and sin omega t minus theta. Okay, So this is our two phases, V and this is I phasor equal to, and V phasor equal to V, that's equal to Vm sin omega t. So the various waveforms, that is V, I, voltage and current waveforms will look like this. So this is our voltage waveform. So instantaneous values. So that is represented by small letter V, and instantaneous value of current is represented by small letter I. So and the current waveform is lagging. Is lagging means it is coming after the voltage waveform by an angle theta. So that means after theta angle only the current waveform comes into the picture. So that is why this the mathematical modeling of this current waveform which is lagging is given by Im sin omega t minus theta. So these are the instantaneous values of voltage and current in that particular circuit. Now we know that power formula P, I am representing it as small letter p, and that will be equal to small letter v into small letter I. So that means this P, small letter p, is nothing but our, again, instantaneous value of power. Okay, instantaneous value of power will be equal to instantaneous value of voltage into instantaneous value of current. So that means the power at a particular time instant of time, let us say t equal to t1, will be equal to V of voltage at that instant, that is V of t1, into current at that instant, that is I of t1. So V of t1 and I of t1 is the power P of t1. So in general we can say that this is P is equal to V into I. So where V, small letter v and small letter I are functions of time. Then we will get the waveform of the power like this. This is our power waveform. So like this. That means if you take this instant of time, then voltage is positive, but the current is negative. So positive into negative, you will get the negative, and here the current is 0, voltage is some positive value, so positive into 0, so 0. So power is 0 at this instant of time. Then again you have positive at this time instant we have positive voltage, positive current, so positive into positive, positive again, so power will be positive. So like this we will get the power, instantaneous value of power, like this, that waveform. That means again we have the positive values for power, and also we have some negative values of power also. So what do you mean by positive power and negative power? Power positive means power is always drawn by this load. That is, the direction of power flow will be from source to load. So from if the power is flowing from source to load, then the power is considered as positive power. Then negative power means the power is flowing from the load to source, like this. like this. Okay, so that means for some duration, okay, for some considerable duration, the power is flowing from source to load, and for small duration of time, the power is flowing from load to source, load back to source. Okay, in that case, then the net power flow from the, yes, the net power flow, okay, that means positive power flow from source to load is named as the average power average power consumed by the load. So that means you have to take the average value of this. So average value and RMS value of any waveform you have, you know how to calculate it. So if you if you calculate the average value of the power waveform, then it is represented. It is notated by capital P, and that will be equal to V RMS into I RMS to cos of angle between V phasor and I phasor, that is theta. Okay, so you will get this equation. This is our, yes, I will prove this also. This also we have to, okay, if you have any doubt, then I will prove it. So average value of power, it is notated by capital P, and that will be equal to, yes, 1 by total area divided by the base value. So base will be again the time period, that means the period, the cycle, duration of cycle at which the waveform is got repeated. So that will be again, it is 2 pi. So 1 by 2 pi, that area will be nothing but integral from 0 to 2 pi, okay, V of t into I of t. So not actually V of omega t and I of omega t, okay, because it is a function of time, and if you multiply that with omega, then you will get theta. So it is again a function of theta also. So you can write V of t or V of omega t also. So since we are going to calculate the area, so our x-axis is theta angle. So I'm considering this is V of omega t into I of omega t d omega t. Okay, so if you do this, okay, finally you will get P equal to average power, and that is known as the real power, or that is known as the active power. So these are the different names of this average power, and that is equal to VRMS into IRMS into cos theta, cos of angle between V phasor and I phasor. And this V, where VRMS will be equal to Vm by root 2, and IRMS will be equal to Im by root 2. Okay, so this will be our active power. Another term is related to this, again the, yes, we have the average power equation like this, and this term corresponding to the multiplication, that is VRMS into IRMS, is our VRMS, that is VRMS into IRMS, is known as another power, and that is called as apparent power. Apparent power. Okay, and cos theta, that is cos of angle between uh, the two phasors, that is V phasor and I phasor, is known as power factor angle. Sorry, power factor, not angle, power factor. And theta is known as the power factor angle, phase angle, and also power factor angle. And this power factor is defined as, so the power factor we can define, actually we are going to rewrite this equation, that is capital P. So capital P is nothing but our real power or active power or average power, anything you can call it. Okay, so real power is equal to apparent power into power factor PF. So that means power factor, you can define like this. The power factor is the factor by which the apparent power is multiplied in order to get the real power consumed by the load. Okay, so that means the apparent the power factor is defined as the factor by which, that is power factor cos theta, which will be less than 1, that factor by which the apparent power is to be multiplied so as to get the average power or real power of the circuit. Okay, where angle theta is our phase angle, and if the current I lags the voltage V, I lags V, okay, I lags V, as usually the case usually we take like this, then the power factor is called the lagging power factor. If that means if I lags V, and if you find out the cos theta, then this is known as the lagging power factor, lagging PF. And okay, and is always positive. Okay, and on the other hand, if the current I leads, so there is a chance that current I leads the voltage phasor V also. Okay, then the power factor is called the leading power factor. Now again we have the possibility that the V phasor and I phasor is exactly coincides like this. So in that case, the power factor, the angle theta, phase angle, will be equal to 0. So cos 0 will be equal to 1, and it is famously known as the unity power factor. Okay. Yes, and also if again the phasor V and the current I phasor is lagging the voltage phasor V phasor by, if the angle is 90 degree, then the power factor will be cos 90, and that will be equal to 0. So 0 power factor ZPF. And also again, if the I phasor is leading the V phasor by an angle 90 degree. Okay, then also cos 90 degree, that will be equal to 0. So whether it is positive or negative, it doesn't matter, because cos of minus x is equal to cos x. Okay, so that doesn't matter, but you have to mention that whether it is leading 0 power factor or lagging 0 power factor. Okay, so lagging 0 power factor means the I phasor will be lagging the V phasor exactly 90 degree, and leading 0 power factor means the current phasor is leading the voltage phasor by an angle 90 degree exactly. Okay, so these are the possibilities of, and also, and yes, theta is ranging from minus 90 degree is than or equal to theta, and less than or equal to 90 degree. So then cos theta value will be ranging from 0 to 1. Okay, yes. So this is the topic of average power, that is active power, then apparent power, then phase angle, and power factor. Then we have discussed the different power factors, that is lagging power factor, leading power factor, then unity power factor. Okay, so thank you.